I'm Susan Mullally. I am the JWST Deputy Project Scientist at Space Telescope Science Institute, and thank you so much for joining us today. I'm going to give the webinar on JWST for beginners. I'm assuming that you haven't really spent much time thinking about JWST, and so kind of just give you an overview of some of the resources that are available to you. So just to introduce you to the telescope, this is the James Webb Space Telescope. It is a 6.6 meter diameter telescope that will be operating in the infrared. It has a variety of imaging and spectroscopy modes, and more than 90% of its time is open for people to propose to use this telescope. It was built as a partnership between NASA and the Canadian and the European space agencies. So why am I talking to you? I work at Space Telescope Science Institute, and we're in charge of sort of the operations of this telescope, which means we care a lot about being able to execute your science programs and that you can get the most science out of this amazing observatory. And so what I want to do today is give you an introduction to some of the resources you have at your disposal to go about doing that. So your homepage as a scientist who is thinking about using the James Webb Space Telescope is this website, jwst.stsci.edu. And so here's where you will come to find resources that you need. It's kind of your homepage to find everything else. If you're looking for documentation or what the call for proposals is, here's the place where you want to come. So let's dive into the timeline as to where we are for JWST, and let me convince you that maybe now is the time to jump into thinking about using this observatory. So you just missed the cycle 1 deadline, which was back in November 2020. But even if you didn't put in a proposal, no worries, there's still plenty you can do. The telescope is planning to launch in October this year. And after that, it goes through a 6-month period of commissioning, followed by science data coming out. And some of the first science data that will be taken is this early release science programs, which is 460 hours of data that will be public the moment it hits the archive, which means that anybody can go in and see what the JWST data looks like and see what the performance of the telescope is. In order to get ready to do that, Space Telescope is hosting data analysis training events called JWebinars that will allow you to familiarize yourself with some of the data analysis tools, what the formats of the data will look like, how to work with these data. So those who attend these data analysis training, take advantage of some of these early release science program data, will be well positioned to write a very successful cycle 2 proposal, probably at the end of 2022. So that was sort of a quick overview of the high-level message of this whole talk. So let's get into some of the details of what all that means. So here's a quick overview of the telescope, some of its instruments and modes, all the capabilities of the telescope. So JWST has a primary mirror that is 6.6 meters, as I said, and it's made up of these 18 hexagonal individual mirrors that all work together to reach that collecting area. Its collecting area is about 6 times larger than that of Hubble and 50 times larger than Spitzer, and it's operating in the infrared. And to enable us to do that, it's orbiting the sun at the Sun-Earth Lagrange 2 point. And by being way out there, it allows us to keep it nice and cool and but still have decent communications with it. And so you might think about what sort, by these improved sensitivities and at these new wavelengths that maybe we haven't looked at the universe before, what kind of science can we do? And just as an example, to inspire you to think about that, Hubble took this image of the Pillars of Creation, which is a nebula, part of the Eagle Nebula, some 6,500 light years away. And when you look in the visible, you can see that you see the dust and you see the gas of these pillars where star formation is going on. But if you switch over to the infrared, you see the universe in a whole new way. And the starlight is able to pierce through all that gas and dust. And now we can actually look at where stars are being born. And so JWST, which was optimized in the infrared, and it will allow us to observe in the near and the mid infrared. Will enable us to look at the universe in a whole new way. And so I'm hoping that you will take this opportunity to think about what JWST can do for your science. And so in order to enable that, there's a wide variety of instruments and observing modes on JWST. And so here's what the focal plane looks like with the detectors. And there's 4 main detectors. There's NIRCam in the middle there, NIRSpec off on the left, MIRI, our mid-infrared instrument, on the right, and NIRIS down towards the bottom. And if we just walk through quickly some of the capabilities of these instruments, on the next slide, you might just, you can't go through them all because there's a lot, but just give you a sense of all the different things you can do with this general purpose observatory. If you're interested in imaging, you can find that on NIRCam, MIRI, and on NIRIS. If you want to do coronagraphic imaging and look for things like dust and exoplanets around nearby stars, go look, you can do that in the near and mid infrared with NIRCam and MIRI. There is a multi-object MSA, multi-shutter assembly, allows you to put slits exactly where you want on top of your objects and get dozens or hundreds of spectra all at once. If you want to get spectra across like a galaxy to study its kinematics or its structure, you can use the IFUs on MIRI and NIRSpec. And there's also long and slitless spectroscopy on NIRSpec, NIRIS, and on MIRI, and you can use these in a time series mode, which people are planning to use to study the atmospheres of some exoplanets. So this just to inspire you to think about, well, I have a lot of options of what I can do with this, and if I'm interested in the near infrared, what can you do with this sort of telescope? And I'm asking you because we want you to be our guest observers for this telescope. And as you start to think through those questions, well, how much time will it take to do the observations I have in mind? This tool might become handy for you. It's called the JWST Interactive Sensitivity Tool, or the Jwst, and allows you to really kind of get a sense for different observing modes, how much time you're going to need on this observatory across different wavelengths to reach the signal to noise you need to do your science. And so I recommend checking this out. Now, as you tackle the idea of observing with this telescope, there's sort of a few quirks that you might want to consider. And you'd find these as you read the documentation, but I just wanted to bring them up. The first is that JWST can't point everywhere all the time. This is because we have to keep it in the shade of the sun, that big star shade at the bottom, the telescope size, those layers that keep it cool, need to keep the hot side hot and the cold side cold. And so that means the telescope can only point between 85 and 135 degrees, but it can do that in 360 degrees, which means over 6 months you can observe anywhere, but at any one time, there's only certain places you can observe. But things near the ecliptic poles can be observed anywhere. That's the continuous viewing zone. So keep that in mind as you think about planning your observations. The other thing, at least I found interesting as I started thinking about infrared astronomy, is that we read out the detectors differently with JWST. And they use this up the ramp readout. And what happens is that you can non-destructively read the detector, and you can do this in different readout patterns. And you do that over and over again, and that makes a group. And so many groups make up an integration, and then so many integrations make up an exposure. And so when you're trying to figure out your exposure time, what you're actually setting is your readout pattern, how often you non-destructively read the detector, how many groups and integrations then you want to make up your exposure time. We do this, though it seems a bit confusing, you do this to improve the read noise and also to improve cosmic ray mitigation. And the reason you need to understand this is because you'll need to set these values when you're proposing, but also on the other end, when you get the data down, you'll need to understand this to understand the data that you're getting out. So there are several tools for when you get around to putting in your JWST proposal that you should be aware of. One is APT. This is the same tool that's used by Hubble. You put in your targets and you can set up all your observations in here. And the other one is the exposure time calculator, which can be run in both a GUI at this website, or you can run programmatically, and both are running a code called Pangaea behind it. And you can explore all sorts of different modes and figure out what sort of exposure times you need in order to get to the signal to noise that you need. Okay, but as I mentioned, you just missed the Cycle 1 proposal deadline, so you have about a year and a half before you have to plan your next one, almost 2 years. And so we might want to start thinking about what to do when we have JWST data. And so I will emphasize again that you really should take a look at the early release science programs. These programs, there's 13 of them, were proposed, and they were intended to be a way of making sure people had a chance to see JWST data quickly after JWST starts taking science data. And so they cover a wide range of topics, and each of these proposers also attempted to exercise many different modes that was important for their science. And so you see topics ranging from Jupiter to exoplanets through massive stars and binary systems to galaxies and lensed arcs. So you should find something in there that will help you figure out what are the capabilities of JWST observing in different ways, because you also see that they expand most of the instruments for each of these topics. So, and additionally, each of these ERS programs have a mandate to help their community learn how to use JWST. So many of them will be coming out with various products or training resources to figure out how to use these data. So keep these data in mind. So you want to go after one of these ERS programs. Where will you go once the data starts coming down? And that you'll do by going to the MAST. This is the Mikulski Archive for Space Telescope that's hosted at STScI. You use the main portal, which is at archive.stsci.edu, and you can do a cone search, or you can do an advanced search for exactly your program ID. You might have to, this is the main portal for all the data at MAST, so you might have to filter by mission, by JWST. You'll notice right now all the things that were returned on this figure are orange. That's because they're all proposed. They're not actually data in there yet. But those will all become normal rows starting next year. Okay, so you have your data. What resources are available to learn how to use these data? You have the JWST pipeline is being developed, and it's intended to calibrate the data and produce science-ready data products in some cases. It's intended to be something that you can install on your machine, and you can rerun on the data once you have it. It's highly modular, so if there's parts of it that you would like to change slightly, you can do that. You can also just change how it was run by changing some knobs here and there. So you could look into how to run the JWST pipeline. There are also data analysis tools that are being written to, they're flexible tools to help convert those pipeline products into then your scientific results, and they work alongside AstroPy and primarily written in Python. You can install these through the Astroconda package. There's also visualization tools called JDA-Viz, and these are intended to be visualization tools to help you interact and do that initial data exploration that you're doing. I have a couple of screenshots of that. For instance, you can load a whole spectral cube in here, or you can pull up a simple spectrum and measure a full width half max. So you should take a look at these JDA-Viz tools and see what they can do for you. There will also be links from the MAST straight into these tools as well. So how can you learn all this? It's a lot to take in. So JWST has a notebook repository called JDAT_notebooks on GitHub. And if you go there, you will find a bunch of notebook tutorials that provide example data reductions for several science cases. And they all use either similar data or simulated data. And they take you through different examples. So those tools will be developed over the next year. We're also starting a training program called JWebinars. And these are intended to be virtual small group interactive training sessions, and they'll be announced at the town hall today, which is going to be in about 20 minutes, so right after this webinar. So I highly I recommend going to see that. All right, and so then before I leave you, I wanted to tell you about how you can get more information about all of these things and more. And so the first thing I want to emphasize is that the moment that you get really confused, and you look through the documentation, you can't figure out how to answer this question, there's an amazing JWST help desk, which is the website here, also linked from the main web page. And you can, all you need is a MyST account, which you need for using any of Space Telescope services. And from there, you can ask a question. They're amazingly helpful, and they really want to make sure you're able to do your science using the JWST telescope. Most of the documentation is stored in something called JDocs. This is a Confluence instance. It allows us to keep it up to date. It also makes all the documentation indexed by Google. So when you do your Google searches, you'll find yourself here a lot. The way you navigate this is using that bar on the left in gray, and you'll notice that there's high-level topics, like, oh, here's a basic idea of the thought process you might go through for proposing. Also, really deep articles on exactly the information you need about particular instruments. It's all in here. As things change with JWST and things become and news and events happen, you can keep update with those with the JWST Observer. That is linked from our webpage, as you can see here, or you can follow us on social media if you're on Twitter or Facebook. Just look for JWST Observer. JWST Observer also has a YouTube channel that you can subscribe to. It's a great place for short videos about how to use our different tools for various things. So these are like usually 5 to 10 minutes, but there's also longer talks, for instance, about the ERS programs that you might want to go watch. And finally, I'll leave you with the thought that the JWST Users Committee is a resource for you to think about. They provide advice to the observatory as a whole. This is the current members of the committee. Some of them are rolling off soon, and so we're looking for new members. But you can reach out to them by going to the website and go under Science Planning and go to User Committees. Then you can email the JSTUC chair if you have questions about or suggestions for what would make the observatory run better. So I will leave you with this final thought that the JWST Town Hall is today at 1:40, where you'll hear more about what happened during the Cycle 1 submissions and also find out more about those J webinars I mentioned and the JWST project status as well altogether. And then finally, I want to take a moment to suggest that all of you take the JWST Cycle 1 user survey.